So first, when we look at the new data set, we want to understand what a row is in the table. In this case, it's easy to understand. That would be the employee, and the primary key would be the ID right here. Let's see, the next one we have department, just a table with departments and their IDs. So most likely this and this are the same. Now let's see what we have to do. Write a query that calculates the difference between the highest salaries found in the marketing and engineering departments. Output just the absolute differences in salaries. Okay, so let's read this again, keeping in mind the SQL lingo. Highest salaries. So that sounds like a max aggregation found in the marketing and engineering. So that sounds like we have to filter for these, and we have to filter for the varchar values. So we have to join these two tables based on this one, the department ID, and we're going to filter based on this one right here, and highest salary. So we're going to have to do a max on the salary. Then we have to output the absolute difference. There we just use the absolute function. First, let's just say select. Let's do our join first, db employee. We're going to name it E. Then we're going to join it with db dpt. And our key is going to be E, let's see here, ID, and then, no, it's going to be department ID, E department ID equals with, and here in the database dpt, we're going to take the ID right here, ID. So now we have joined it. Now we have to create the max. In the end, we're just going to want to have the absolute of two max values. So we're going to write absolute there, and then we need a max here minus another max here. This line right here, this line right here would be the maximum for, let's say, marketing, and the one below would be the maximum for the engineering one. Now here we can use, in this particular case, we can actually use a case. We can say case, we can filter using this one, case where the D department equals, and now we say the department, marketing. We could say either, we could say marketing first or engineering after. It doesn't matter because the final value is going to be absolute anyway. To finish this one off, we're going to want the salary. We're going to end this here. Now we just copy exactly the same thing and we just modify here, engineering. There we go. So this should be our final code. We're just going to indent it here to look easier to read. So let's see what we have here. First, we are joining this table, the employees, with the departments so that we have access to this one, because we have to filter based on this one, on the actual name of the department. And then we select, we want the final output needs to be just one number, the absolute value between highest salaries. So we need to find highest salary for the marketing and then highest salary for engineering department. So this is our filter right here, the D department. Then we request the salary and we finish it off. There's no need to use anything else. We just end it. Now let's run the code. Let's see what we got. And we got here, wow, this is a not so pretty. Let's just rename this. I'm just gonna call this as salary difference. Let's call it like this. Looks more organized. That looks a lot better. Now let's see here, expected output 2400. There we go. So that was the solution for this one. Let's go to the next problem. Problem number 2, employees with bonuses. Let's check what we have to do. Let's check out the table first. Employees. So a bunch of data about employees. This seems to be the primary key, the ID. All right, let's check out what we have to do. What do we have to do? Find employees. So rows. An employee is one row. Find rows whose bonus is less than. Now, we read this in terms of SQL. We have to filter this column, the bonus column. This one here, where is it? Bonus, integer. We have to filter to be less than 150. Output first name. along with corresponding bonus. So that would be just bonus from employee. That would be the table. And now we have to filter. Now we're going to say the bonus to be less than 150. That's actually it. We don't have to order, we don't have to do anything else. Let's see, Brittany, 100, everything seems to be fine here. Yep. That was for this one. Pretty easy. Okay, problem number 3. Total AdWords earnings. This one is from Google. Let's see, let's look at the data first. We have, let's read in the title first. Earnings. That doesn't really tell us what kind of earnings, so let's see. We have business type, a bunch of number of employees, so it seems there's information, earnings per business type. Now let's see what we have to do. Total, that could be a sum or a count, that depends on the situation. Total earnings for each business type. For each business type. That sounds exactly like a group by. And now let's see, output, the business type, business. So it's just going to copy it from here, business type, and total earnings. Now let's see if the total earnings in this case is a count or a sum. In this case, it is a sum because the values here are more than 1. They're massive. So we're going to take this, we're going to say sum of the earnings from, we're going to copy the table name, and now we have to say group by, and here we could just say, we could say this business type, and that would be actually the final answer, like this. Let's see the expected output. Media, 2400 media. Okay, let's check the solution. Should be fine. Yeah. Another thing we can do here, we could just say 1. If you count here, let me try to do, this would be the first one. This would be the second one, you know, third, fourth, fifth. So here we could just say 1, which would be just this one. If we say 2, it would group by the next one. So if you have like really weird names here, you want to do something really quick, you could just use numbers. But if you're going to reuse the code later on, it might be, you know, confusing, like what exactly did I mean? It's safer to just write the actual name. Then you know, okay, business type. I don't have to look up here, and then who knows, the gap between this row and this row might be massive. That's it for this problem. Let's move on to the next one. Okay guys, problem number 4 right here. 2 more to go for this video. Here we have 2 tables. We have employees and survey results, it seems. Employees here, primary key, ID. It seems we don't even have names here, just age, gender, and the seniority data. And then we have the survey results, where we have the employee ID. Okay, so that seems to be this one, an employee ID. This is the common ground here. Probably we're gonna have to join that. Now let's read here. Okay, Facebook has developed a new programming language called Hack to measure popularity. Okay. Ran a survey. Survey included data on previous programming familiarity, number of years. Okay. Due to error, data was not collected, but your supervisor demands a report showing here. Let's check here. Average popularity by office location. So these are the keywords here. We have to translate these in SQL. Average popularity, it's obvious we have to use the average aggregate function on the popularity, and then by office location, that's a group by on office location. Luckily, the user IDs of employees were stored based on the above. Find the average popularity per, okay, so that's what we have to do. Find the average popularity per office location. Output the location. Let's see the output. Select from, let's do the join first. Let's see here, Facebook employees. So I'm just gonna copy these really quick so I don't have to scroll down. All right, from this one, we're just gonna call it E. We're gonna join with the other one on the common values. We're gonna call it S. We're just gonna look at this, right? Employees and survey. And then we're gonna join it on E. Let's see, we want to take the IDs here and the employee ID here. So we're gonna take EID and S employee ID. EID equals S employee ID. We're going to separate this to make it easier to see. Now let's see. In the select clause here, what do we have to output? location. Where's the location? Location seems to be here. E location. E location. And average popularity. So I'm gonna have to do average popularity. Let's see where that one is. S popularity. Now, a thing to note, we don't really have to type this, the S dot and the E dot, because these location is unique. It's not a duplicate. If we would have location in this one and location in this one, then we would have to specify which one we want. It's easier to read the code if we do it like this. It's not much more to write. Let's read this again. Output location with the average popularity. We have to group by the E location, because we have to find the average popularity, and we are doing that right here. Average popularity. And then per office location. That means that sounds exactly like a group by. So let's check this code out. Those are the results. Here we have the same results. India 7.5, UK 4.3. They're in a different order. Actually, I don't know why they're in different order. We're gonna go on to the last exercise, guys. And here we are with the final exercise for today. Finding updated records. Let's see what this one is all about. Preview the data. What do we have here? Employee salary. Primary key seems to be the ID. Salary. Okay. This looks like information about employees. Okay, easy to understand. Let's see what we have to do. We have a table of employees and their salaries. However, some of the records are old and contain outdated salary information. Find the current salary of each employee. That sounds like a group by. Assuming that salaries increase each year. That sounds like we have to use a max. Output their IDs. Let's start from there. Let's write the basic here. Now let's see what we have to output. Output their ID. Now we could just write this. For the salary, we have to use an aggregate function. So we actually have to write all of them manually. First name. What else do we have here? Last name. Then we have department ID, and finally salary. So salary, because we're gonna be doing the max. We're gonna find the max because it says assuming they increase each year. So basically the maximum value of them. Now we have to group them by, let's see, find for each employee. Now each employee, we could actually go by ID or by first name, but this seems to be the primary key and we should actually use this one. Okay, we group by ID, so for each employee, and then do we have to order your list by employee ID ascending order. Order by ID again, and we don't have to write anything. That's going to be ascending, or we can just write ASC and it's the same outcome. So let's run this, see what happens, and we get an error. Let's see why. Select, I wrote the select wrong. Okay, we are back. These are the final results. 110, 130, 42, 170. Seems to be fine. Let's check the solution, and it seems to be correct. So that was for this video, guys. Thank you for coming, and I hope you learned something. If you want to solve these kinds of problems yourselves, I highly recommend joining the website StrataScratch, amazing resource for practicing real SQL interview questions. Please consider using the affiliate link in the description. That's going to help tremendously for someone like me, a very small creator. Thank you, and see you in the next one.